All right, everybody, we're going to talk about angles of rotation in this section and in this video. So I want to remind you, in geometry, we talked about different types of angles. The first type you probably talked about was an acute angle, where the measure of the angle is less than 9 degrees. And then, of course, there's a right angle, where the measure of the angle is equal to 90. And then when it's bigger than 90, we call it obtuse. And you may have even talked about outside angles, which look kind of like an obtuse or an acute or a right angle, but instead of talking about the smaller angle between the things, we talk about the angle outside that. And those tend to be between, somewhere between 0 and 360. Now, we can also talk, however, about angles that are bigger than 360. And if you've watched any sort of skateboarding competition or snowboarding competition or a slam dunk contest or figure skating or dancing even, you might be familiar with the terms 360 or 720 or 1080. And those refer to a full revolution, 2 full revolutions, or 3 full revolutions. And in snowboarding and skateboarding, they even go by half revolutions as well. So you might have something like a 540, which is a full turn and another half turn. Now, those are examples of angles of rotation, and their measures are all based on things that are 360 or bigger, because they represent how much we've spun, basically, in a full circle. So mathematically, we have angles of rotation too. Now, what I'm about to show you is what's called standard position of an angle. And this is what we're going to use to sort of describe angles mathematically. Instead of just having them hang out in open space like we did in geometry, we're going to place them on an X and Y axis. Standard position always has the angle's vertex at the origin. There's an I in the word origin, 2 I's in fact. And then there's 2 rays that make an angle, right? Those are called the sides of the angle. One side of an angle will always be attached to the positive x-axis. This is called the initial side because it's the side the angle starts at, and it's always attached to the positive x-axis. And then you have the other side that sort of marks where the angle ends. So let's say I had an angle of like 120. That would go up past the y-axis and another 30 degrees, right? Because the positive y-axis is a 90-degree angle. The side that ends the angle is called the terminal side. And where it lands depends on the size of the angle. So we would call this a 120-degree angle. Again, initial side always starts at the positive x-axis. Terminal side always ends wherever the angle measure dictates. Now, let's say I was drawing an angle that was bigger than 360. That would be tough in my old geometry way. But when I use the standard position stuff, it becomes a lot easier. So let's say we're trying to draw an angle of 480 degrees. So what I'm going to do here is I'm going to draw an initial side, again, always on the positive x-axis. And here I go. I'm going to go 90 degrees, 180 degrees, 270 degrees, 360 degrees. Now notice I'm forming a spiral here so I can see how many times I've gone around. That's 360, 450, and I need to go another 30. So about right there-ish is where my terminal side would end. So you see that the 480 terminal side and the 120 terminal side both ended up 30 degrees past that 90-degree angle. You can tell they're different angles because in the 120, this is how far the terminal side went. And in my 480, it went all the way around. And even though it landed in the same spot, it's a different angle measure. Basically spun around a full time and then went another 120 degrees. Now, any angles that share a terminal side, like these two do, have a name. These angles are called coterminal angles. And they're angles that share a terminal side. And remember, in standard position, all angles are going to share the initial side. It's the terminal side that makes them special if they share that. So now we have a way of representing angles that are bigger than 360. We just mark it with our angle thing in a spiral, going on the appropriate number of times and landing in the right spot. Now, this standard position also allows us to talk about negative angles. And you may think about that and call, what? Negative angle? What does that even mean? Well, a negative angle, let's say negative 240 degrees, if you place it in standard position, ooh, that's a terrible axis. Let's fix that. That's a little better. We always, again, put our terminal side on the positive x-axis. But this time, because we're going negative, negative is a direction that we're going to spin. The positive spinning direction moves the angle like up into the first quadrant, and then into the second quadrant, and the third quadrant, and then the fourth quadrant. By the way, that's the reason the quadrants are numbered 1, 2, 3, 4 in that order, because if you move an angle positively, it goes through those quadrants in that order. So if I have a positive measure, it's going to go up from the x-axis. If I have a negative measure, it's going to go down. So basically, I would do this angle the same way I did the others, where I count out where I need to land, but this time instead of going up, I'm going down. So here we go. Negative 90, negative 180. If I went all the way up to the y-axis, that'd be negative 270. That's too far. So another 60 degrees. So about right there. And that's negative 240 degrees. So positive angles move up, negative angles move down. Terminal side lands wherever the angle dictates. We use our angle marker to mark how many times we went around. And the initial side is always on the positive x-axis with the vertex at 0. So we will talk in a next video about something called reference angles.